So guys, we are going to look at our part 2, building lambdas. So we are going to review the following functional interfaces for building numbers. So we're going to start with the predicate functional interface that comes with the JD. Okay, so for now we can even delete this, we don't need it. So what we're going to do now is we want to use predicate. First of all, let's see how it looks like. So as you can see, it contains an abstract method test. We don't care about the other methods we saw, as long as we have one that is abstract. And we see that it's also a functional interface, which is you want to enforce the behavior at compile time, so that if it's not, your class should not even compile. So we see that this is generic, receives parameter t and returns boolean. So what we want to do, we want to write a simple code to determine if a number is odd number. So we're gonna say predicate, since it's a number, you can just say integer or number. Let's just put number is odd, equals, you see we are receiving parameter which should be of type t. In this case is of type number I. Then we want to check if that number is odd, so we can say I divide by 2 equals to 0. So we see that it's not allowing us to do this. So the reason it's not allowing us to do this is because this is a number, it's abstract thing. So we can come here, we see it's abstract. So we have to mention that one of its implementation, we can say integer, then this should work. So if we say equals to 1, that means the number we have given is odd. So we can now say out is odd. What number we want to give is odd dot test 9. Then we run this code. See, it's false. Let's pass 8. Why is it saying always false? Why is it always saying false? So this is not what we have to say. We have to say modulus 2. So what was happening here, we are saying I divide by 2, then we check if it's equal. So what we need to do is say I modulus 2. When we divide I by 2, do we get remainder to be 0? That's the meaning of that statement. Then we say it's false. If we give 9, you see 9 is an odd number. And observe here, this 9 we are passing is an integer. But because of auto-boxing, this will be auto-boxed to its corresponding wrapper class, as we mentioned in our previous tutorials. So this is a typical usage of our own usage of predicate. At the end of this demonstration, we will check how we are using predicate in other Java APIs. So we will demonstrate that at the end. So for now, we have dealt with predicate. So what you have to know is that predicate is a functional interface that contains this method test that returns boolean, as we saw in our slide. Then consumer. So okay, before I even go there, you can do several things here. If you do not want to do this, you can return here, because that function actually returns something back to you. And then if you want to do a return, that would mean you will have to put it in braces like this, then return, then here provide closing. You can do this if you want to do this. Also, I mentioned in my previous tutorial that this type here is inferred. You don't need to provide the type. Okay, that's fine. Then let's look at the consumer. So what the consumer does, we see that consumer has method accept, that is void, that takes a type parameter. So we are accepting an integer here. So what we can do, we can print that integer. So we can print it. What do we print? We are printing, I don't want us to do method references now. We can do this. We can print a number passed to us, which is x. So here we just say accept. Is it consumer? Okay, let me see. It's accept t. Yeah, that should be fine. Let's see what is wrong here. Dot accept. We are accepting an integer 9. Oh, I see. It's doing this because the accept method returns void, and we are providing that into the system.out, which does not make sense, because system.out.print accept a parameter. That's why it was giving us an error. So here we are able to print this. So let's go back to what the code was trying to do for us. You saw that it did this for us. It actually did this for us, which we can now say accept. So we can say resort, although the name is not really correct, can do this, and it will still print 9 for you, as you can see. So let's go back to the method that we previously had, predicate. So what we can do, we can do the same thing. We can say public static boolean is odd, and this receives integer I, and then we just return this. So what we have done here, we have removed the implementation to outside. So now we can do this into our code as a method reference. So now if we say is odd dot test 9, and then see out this, we are still going to get true as we add with the other one. So what we have done here is a method reference. So if you do this, the method definition of this method, static method, must be the same as the method defined in the functional interface. here. We say it returns a boolean and it takes type t. So this one returns boolean, it takes integer, as we have here. Let's see what happens if we put long here. You see, obviously it doesn't work because the type that is expecting here is a long. So it will work if we put long here, but it's finding an integer. That's what we have to reduce, assuming that this was not static. If this was not static, it would mean now that we have to use main. We have to use it like this: main and do is odd. It's the same thing. Then it should work when we run this code as method. Although we're going to have a separate video for working with method references, but for now it's fine. This is where now when you have consumer, as we said, I'm gonna delete this, guys. When you have consumer and then you say this is out, it does this for you automatically. And if you say is odd dot accept, what are you accepting? 9. It's going to print this for you in the console. This is what the method reference that we just explained actually means. I hope that makes sense. Then we have seen how a consumer looks like. Then this is a function. So a function receives t, parameter t, and returns t. So that means a function has two parameters. So if I say function, I will have to provide, okay, we are receiving a parameter. We can say integer, boolean. So what we want to do, we want to check if a boolean is odd. So we can say, sorry, an integer is odd. So we can say is odd. So what we do here, we say equals. We know that the first parameter is the one we want to check whether it's odd or not. Then sorry. So what we can do, this is not a good example, I get. So no, this is fine. So this is fine. It's a good example. So then what we will do here, we will say return. We can just say return true. So this is a perfect implementation of the function method. So what we could do then, we could say x mod 2 equals to 1. So this is, we are checking if the number that we are passing is an odd number. So the way to use this, you can say out is odd dot apply. So what's that number? It's 9. 9 is an odd number. As you can see, it's true. 9 is an odd number. So in this definition, the first type parameter is an input to a method apply, and the second is a return type. So if we come here, we see that the first t is an input t, the return type r is a return type here. The second parameter r is a return type, sorry, as you can see. So this is how you can use this thing. You can also apply the same thing here. You can say public, as we did, static, boolean. Boolean, we can say is odd. It receives an integer I. And here you say return I modulus 2 equals to 1. Then what you would do here, you'll say main dot is odd. It's still the same thing. You are providing your own implementation for function interface. So as I said, for now, we are not going to show you how the Java API uses this. We will see where it's been used after this particular one. We just want to explore how to use it. So we see how we can use this one with method references. So we already saw that if we want, we can remove this functionality here and specify those parameters. We can say T and R is a return type. Then here we can say, and then obviously, so we have to say return T. Sorry, it doesn't have to be here. I always confuse this. We can implement it like this. This is also correct because this T is an input. The return type is what we are returning here. And if you run this code, you still have the same behavior. If you put 11 is an odd number, this should be true. As you can see, it's true. So that is it with a function. Then we have supplier. Supplier has one method called abstract method called get. That just returns a type parameter you're given. So let's say this one is a supplier. What we want to supply is string, and then we return that string. It could be, let's just say reverse of that string, or maybe to uppercase, to uppercase, just for demonstration purposes. So you can say so we see this one does not take an input. If you can go here, we see we have get no input, just return something. So what you can do to uppercase that will not work. So let's say a proper example would be an int where we say random. That's a proper example. So this just returns us a random number. So we can say new random dot next int provided okay, let's say, okay, that should be fine. We can, what we can do is we can say integer dot what we can do, value of it says change random to type integer. Okay, let's see. No, we don't want to do this. Yeah, so what we need to do here, we need to do this. Sorry guys. Yeah, the lambdas, sometimes they can fool you. So we have to say random dot get. So it will actually give us a random number. It's always correct sometimes to make mistakes, because that's how you learn. It gives you that random number. Okay, let me see. Does this one? I don't even know how this one is implemented, but let's see. I think it will give you a random number below 10 every time when you run it. Yes. Yeah. So this is how a get will work for you. So you use it when you want to get something based on nothing. As you saw that its get method does not get anything in as a parameter. So this is how you use the get. Or you can use a method reference the way we have been using as you saw guys. So in a nutshell, this is how the basic built-in functional interfaces you can use for your own code. So guys, we saw how we can use lambdas or method references with static methods, instance methods. We can also use method references with constructors. So I'm just going to show you quickly how you can do that. Let's say you want to get an object of type main. So we can even leave it like this because we have a default constructor. So what we could do here, we could say main, then we can say new, but we have to provide main here as our parameter. So the object we are getting here, if we say .get class .get name, it should give us the main method the main one that we just had here, lambdas main. As you can see, let's run it with just .get class lambdas .main. So this is how you'll typically do it. Let's assume that we have a default constructor. Sorry, we don't have a default constructor. I mean, we have a constructor with argument int I. How will you then do it in this case? Would you say 9 or would you say 9? So you see what issue you are having here, that when you have a constructor with argument, you are stuck. So let's try this new main 9. You see, you cannot even do this, so you are stuck.